Now we're going to take all of our knowledge of rational functions and sketch the graphs. So this is a pretty step-by-step process of how I want you to graph the rational functions. Now step 1 and 2 can be interchanged, and that's not that big of a deal, but make sure that you are finding all of the asymptotes, vertical and horizontal, finding all of the holes, finding the x and y-intercept before you start graphing. Before we sketch the graph, we have to find all of this information. So my first step is always to factor. So I'm going to factor the numerator. Factors of 9 that add or subtract to give me 6 are 3 and 3. Same, both positive. Now I have a term that matches from the numerator and the denominator, so that will divide out and leave me with f of x equals just x plus 3. Now because I have a term that divided out, I know that that means I'm going to have a whole. So I set x plus 3 equal to 0, and I will have a whole at x equals negative 3. To find the y coordinate of that whole, I take my reduced function and plug in negative 3. So I will have a whole at negative 3, 0. To find any vertical asymptotes, I look at my reduced function. Now that I've removed the whole, I no longer have a denominator, so I have nothing else causing me to be 0 on the denominator, so I have no vertical asymptotes. Horizontal asymptotes, I compared the degree of the numerator with the degree of the denominator. Numerator is larger than the denominator, which means I have no horizontal asymptotes. X-intercepts, well, x-intercepts occur whenever y equals 0. Well, since I only have a linear function now, I'm going to let this equal 0 for my x-intercept. So I will get an x-intercept when x equals negative 3. Y-intercept occurs whenever x equals 0. So everywhere I see an x, I'm going to plug in a 0. So my y-intercept will occur at 0, 3. And now I am ready to try to graph. So we first start out by plotting all of the known information that we just found. So I know I have a whole at negative 3, 0. So I'm going to draw my whole at negative 3, 0. No vertical asymptotes, no horizontal asymptotes. I will have a y-intercept of 0, 3. Go ahead and label my whole too. I have an x-intercept at negative 3, 0. We'll look at that. My whole and my x-intercept are occurring at the same spot. So that is still a whole. And if you look at the reduced function, you should be able to tell that this is a linear function. Now, if you can't tell that, that's fine. Go ahead and plug in values for x. So if you plug in values for x, let's say I plug in positive 1. Well, if I plug in positive 1, I get 4. Let's plug in negative 1. If I plug in negative 1, I'm going to get 2. Plug in more values. Let's plug in negative 2. If I plug in negative 2, I get positive 1. If you plug in positive 2, I will get 5. Okay, so if you did not see that this was a linear function, you can still make a table of values. So plotting the points I just found in my t-chart here. Now hopefully now you see that it's a linear function, so I'm going to go ahead and graph that line. It's very important that you make sure that you skip over the hole, okay? We are leaving this hole open. My function does not exist there. That's my removable discontinuity. And here's the graph of this rational function. Alright, so now let's give this one a try. Y equals 2 divided by x squared minus 4. So I want to find all my information. In order to do that, I need to first factor the denominator. Difference of two perfect squares. I have no terms that divide out, which means I have no holes. Vertical asymptotes will occur at any values that will make the denominator 0. So I'm going to set each of the terms in the denominator equal to 0. So I will have 2, one at x equals 2 and one at x equals negative 2. Horizontal asymptotes, I compare the degree of the numerator with the degree of the denominator. Numerator is smaller, which means I will have a horizontal asymptote at y equals 0. X-intercepts mean that I plug in 0 for y, so I set the numerator equal to 0. Now I can never make 2 equal to 0, so I will have no x-intercepts. Y-intercepts, everywhere I see an x, I plug in a 0. So I'm going to do 2 divided by 0 squared minus 4. You could plug into the factored form or the original function. So that's 2 divided by negative 4, so that's negative 1/2. And now I'll have a y-intercept at 0, negative 1/2. So now we take all the information we just found and we put it in our graph. We have no holes, so I go to my vertical asymptote. I have a vertical asymptote at x equals 2. So I'm going to draw my vertical asymptote. Make sure you dash your line or dot your line. And please label it. Now we have a horizontal asymptote as y equals 0, so let's go ahead and write that into our graph. Also dashed and labeled. Now I'm going to insert my y-intercept. So I have a y-intercept at 0, negative 1/2. So I know my graph goes through that point. I have no x-intercept. Now, if you can see, we have 3 different parts of this graph. We have this section, we have this section, and we have this section. So now we know there has to be something going on over here, there has to be something going on over here, and there has to be something going on over here, or else these asymptotes would not exist. Now I know I have a point here, okay? Now since I know I have a point here, I'm going to go ahead and plug in positive 1 and see what happens. Well, when I plug in positive 1 into my function, I get 2 divided by 1 squared minus 4. So I get negative 2 over 3. So I get 1 and then negative 2 over 3. Let's go ahead and plug in negative 1. Well, when I plug in negative 1, I still get negative 2 over 3. Now remember what your asymptotes do to your function. They draw your function in, but your function will not cross the vertical asymptotes. Alright, now that's one part of our graph. Now we need to figure out what's going on over here and what's going on over here. The easiest way to do that is just plug in values. So I know that I need to plug in something smaller than negative 2. So let's plug in negative 3. So plugging in negative 3, I get 2/5. So negative 3 and positive 2/5. If you're still unsure as to what your graph should look like, please pick more values. But this is just a sketch, okay? We are only sketching the graphs. So this is enough because you should know that your graph gets pulled in by the asymptotes. If you are unsure, please pick more points. If you plug in negative 4, you should get this coordinate right here. But if you are unsure at all, you should plug in more points into your table. So now I'm going to plug in positive 3. I'm still going to get 2/5. And again, if you are unsure, you need to pick more points to plug in to your table here. So that is the graph of this rational function. Alright, so now I want you to try this rational function. So you need to find all of this information, and then I want you to sketch the graph. Now please remember that these are just sketches of the graph. They do not have to be perfect, but please include all of this information and then make a T-chart to fill out the rest of the graph.